Want to show you another example of graphing, looking for a solution of a system of linear equations through graphing. However, I want you to notice how these lines are written to begin with. Nobody says they have to be in the the ax plus by equals c format. They can be in any format they choose. So this example I drew out because both lines were in our slope-intercept form, which for me is one of my favorite ways to graph lines. So let's graph both lines. The first line has a starting point at 2 and a slope of -3, which means that my rise over my run, I could go forward 1, rise over run equals -3 over 1. And so from this particular point, I can go down 3, 1, 2, 3, and over 1. And I was able to find that second point and graph that. Again, graphing for me sometimes can be difficult because it's lining everything on up. So that was the first one. The second point is I know I have a starting point at -6. So 1, 2, 3, 4, 5, 6. I have a slope of 5 or 5 over 1. So from this point, I can move up 5. 1, 2, 3, 4, 5, and over 1. And I get my second line. The lines intersect. They intersect in this region. That appears to be the point 1 and -1. I could check that to make sure by plugging this in. So -3 times a 1 plus 2, -3 plus 2 equals -1. That's true for that top equation. And then plugging it in into the second one, 5 times a 1, which is a 5. 5 minus a 6 produces a -1. -1 equals my y, which is -1. So this is the solution set. And how we write that again is we create a solution set notation. That means that everything within this solution set notation is a solution. One solution, in this particular case, the only solution is a coordinate pair, 1 and -1. And so there's my solution to this particular system of equations.